Okay, so the question we were just finishing, we found our acceleration of the system, and then we could go back and we could find the tension, and you could do like some of the forces on M2 and do the tension, and it would be Ft going up, Fg going down, and the Fg2 would be the positive one, so it would be Fg2 minus Ft equals M2A. Or you could do it on this one where it would be Ft minus friction. Okay, so it's just like before with tension. Let's move now to something more exciting, like an inclined plane. So I have one mass on the inclined plane. Its mass is 50 kilograms. So there'll be an Fg1 acting this way. And so Fg1y will be going into the incline, and Fg1x will be acting down the incline. The normal will be acting up, and from all our inclined plane questions, you should know now that Fn would equal Fg1y. Okay, and then we have our second mass hanging over here on this side, Fg2. Now, every time you have an inclined plane, you gotta know which way it's moving, and it won't always be obvious. Sometimes M2 will be big enough to pull it up the incline if the angle isn't too steep. In this example, I made the angle 60 degrees, so this incline is actually much steeper than the way I have it drawn. And because of that, it's going to move down the incline. So down the incline will be positive, and I need to know which way it's going to move because I need to know which way to put friction in. So in this question, friction will be acting up the incline. Okay, so we have 50 kilograms for M1, 35 kilograms for M2. If you were to look at just M1 for a second, then we would find that Fn1 will equal Fg1y. In other words, Fn1 will equal M1g, look at the triangle, cos theta. And we'll need that when we go to put friction in. So then you go, oh, I guess then I should probably draw it in a straight line here. So here's M1 and here's M2. Pulling this way then will be Fg2. And pulling this way will be Fg1x. And because we said it's moving down the incline, also pulling over here will be the friction on number 1 only. Number 2 doesn't have any friction, it's hanging in the air. Okay, so sum of the forces will equal M total A, and because it's moving down, it'll be Fg1x minus Fg2 minus friction on number 1 will equal M1 plus M2 times A. So when we're trying to solve for A, so Fg1 is M1g sine theta, right? That's the opposite side, minus M2g, minus friction is mu Fn1, divided by M1 plus M2. So then A will equal M1g sine theta minus M2g minus mu M1g cos theta over M1 plus M2. And now filling in the numbers. So A will equal M1 was 50 kilograms, 9.81 meters per second squared, sine of 60 minus 35 kilograms, 9.81 meters per second squared, minus 0.3 times 50 kilograms. Gonna run out of paper here. Times 9.81 meters per second squared times the cos of 60, and then it all gets divided by 50 kilograms plus 35 kilograms. Okay, so punch that carefully into your calculator, and I think if you do, you get 0.5253 meters per second squared. So it's going to accelerate down the incline, not at a huge rate because of the block hanging off the upper end, but it is going to accelerate down the incline. Now, if we were to wanted to find the tension, this time it'll be much easier to find the tension on M2 because it'll be just Ft going up and FG going down, and FG going down will be the positive one. If you were to do it on M1, you'd have to have FG1, friction, and tension, and so it gets much more complicated. So on an inclined plane, if you're finding the tension, it's always best to use the one that's hanging off the plane. Now just quickly, I want to talk about what would happen if instead of going down the incline, it went up the incline. And we'll probably run out of time on this one, but we can at least take a look at it. Okay, so here's my M1 again, and it's connected over a pulley again to my M2. And let's make this this angle 30 degrees this time, and we'll make mass 1, I don't know, like 10 kilograms, and mass 2, 18 kilograms. Okay, and I'm telling you this time it's going to accelerate up the incline. So FG2 acting down this way will be positive. We'll have FG1x here, FG1y, the normal on number 1. And because it's going up the incline, this time friction will be acting down. So if we were to do our straight line, pulling this way will be FG2, and pulling back will be FG1x, and friction on number 1. Okay, let's make our coefficient of friction 0.2. And then we'll find A again. And you won't always be finding A, I'm just doing it as an example. So it'll be sum of the forces will equal M total A. And so this time it's moving in the direction of FG2. So FG2 will be positive minus FG1x minus friction will equal M1 plus M2 times A. So again, if we're solving for A, this time it'll be M2G minus M1G sine theta minus mu M1G cos theta divided by M1 plus M2. And then again, fill your numbers in. So really, the only thing you need to be careful of is which forces are positive and which forces are negative. And that all depends on which direction is it moving. Okay, I think I picked this as 18 kilograms times 9.81 meters per second squared minus 10 kilograms, 9.81 meters per second squared, sine of 30 minus, this time I think I made it 0.2 times 10 kilograms times 9.81 meters per second squared times the cos of 30 again. And then divide it by 10 kilograms plus 18 kilograms. Okay? And so then just, you have to punch it in your calculator. And I think you get something really like 3.945 or something meters per second squared. Okay? And then again, if you were to do tension, you would pick this one. Alright, so your homework for tonight, for tomorrow, is going to be the rest of the questions on page 489. So questions 26, 27, and 28. And then if we had been in school today, I would have given you this sheet that was inclined plane and multiple mass problems. And on this sheet, I want you to do numbers 1, 3, and 4. So I'll take a picture of the sheet and post it, and tomorrow I'll give you the actual paper. But 1, 3, and 4 we're skipping 2 because it's not actually a multiple mass, it's just an incline. So you are welcome to do it if you want, because you're certainly able to. It's just now probably too easy for you because we've gone to multiple mass. And these ones, none of them are incline. The ones in the textbook, 2 are. So you have 6 questions for tomorrow. All right? Enjoy your day.